Now I will explain the tax calculation for question 4. First, I created an interface named tax calculator adapter and defined a getTax method for calculating taxes. This interface is all different regional tax adapters need to implement. Then within the POST system, these adapters are used to interact with tax APIs, ensuring protected variation. Over here, I created a class called Ontario Tax Adapter, which is a concrete implementation of the interface. This method overrides the getTax method. With adapter as an intermediary, I need to consider finding a class within the POST system to interact with the adapter. Based on the information expert pattern, the sale class contains the sale amount, so I choose the sale class. I set the interface reference as an attribute of sale to facilitate interaction between sale and adapter. Then over here, I created a factory class. This factory class returns adapter objects based on different regional IDs. The interface reference in the sale class will be instantiated, and then methods of different regional adapters can be called, ensuring high coherence within the sale class. And back inside sale, I added a getTotal with tax method. That is the interaction point between POST system code and the tax calculation code. This method receives a region ID as a parameter and then pass this region ID to the factory class to obtain the corresponding adapter object. Then I use this object to calculate the tax for each sale line items, and the sum of this provides the total amount after tax. And to mention a specific point, my getTax method takes a money object and an item ID object as parameters. That means this method is for each specific sale line item and can vary the tax rate based on the different sale line item. And this line calculates the tax for each sale line item. And in addition, I also modified the getBalance method of the sale class, passing the region ID as a parameter to call the getTotal with tax method, obtain the difference between the payment and the post-tax amount as a balance. Then looking at the GUI class. In the complete sale method, I required the cashier to input the local region ID for tax calculation. I then print the pre-tax amount, post-tax amount, and the balance. Since I require cashier input within this method, so my main method does not need to be changed, and I can remain the same as in question 3. Okay, in summary, by utilizing the iTax calculator adapter interface and the factory pattern, I ensured low coupling and high coherence in the sale class. The various adapters use the indirection and pure fabrication patterns, isolating the internal POST system from tax calculations. This implies the protect variations pattern. Okay, now we can test this program. First, we start by inputting item and quantity, then input the payment amount and region ID. Okay, and we can get the pre-tax and the post-tax amounts, as well as the balance.